Hello everyone, welcome back to another video. In today's video, we will learn about binary search algorithm. Now expect this video to be a little longer because we're going to divide this video into two sections. First, we'll learn about theory and then we'll go to practical section. In theory section and as well as in the practical section, we'll go in very detailed so this video can get a little longer. So let's get right in. So in today's topic, we're learning binary search algorithm. And we'll learn about two binary search algorithms. First is going to be iterative binary search. So iterative binary search algorithm. And second binary search algorithm is going to be lower bound iterative binary search algorithm. So these are the two binary search algorithms we'll be learning today. Now let us first understand everything step by step, and then we'll gradually increase our complexity. So first of all, let me give you a very simple example. So we'll be starting with iterative binary search algorithm and then we'll move forward. So let me copy this so that you have an idea what we are talking about. So we are talking about iterative binary search algorithm. Now let me give you a very simple example. And by the way, binary search algorithm is used in contexts where you have a very large array, and in that array you want to find out some element. Now, if you want to find out some element, then you have different algorithms, but binary search algorithm makes it easier to search something. So you'll understand everything once we go in deep. So let us learn iterative binary search algorithm. So let me give you a very basic array. So I want my array. So my array is A, and inside this I have various elements. So 1, 3, 10, 13, 17, 18, 19, and let's say 20. Now from this array, let us say my target is to find the element, let's say 18. So let's say I want to find the element 18 from this array. So now to find this element, we're going to first solve this using iterative binary search algorithm. So first of all, so let me open the pen. So first of all, I will have two variables. So first of all, I'll have low. So my low will be 0 and my high will be equals to the length of this array minus 1. So if you write the indexes for the elements of this array, then this will be 1, this will be 0, 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6, and similarly this will be 7. Now you can see that there are total 8 elements. So and we have indexes from 0 to 7. So high will be 7. So we have low and we have high. We have two variables which we need to update, which we need to keep on updating. Now let us go to step 1. So first of all, step 1. In the first step, what happens is that we want to find out the mid value of this array. So to find the mid value, what we will do is, so to find the mid value, what we'll do is we will add the low plus high minus low divided by 2. That should give me the mid value. So low, so mid is equals to low plus high is 7 minus low divided by 2. And this would give me 7 minus 0 would be 7. And if you divide 7 by 2, this would give me 3.5. But here we're doing double slash. So if you round off, that will give me the base. That would be 3. And 3 plus 0 would be 3. Now, in the third index, in the A, there is 13. So from our array A, the third index is 13. Now compare our target with this. So 13 and 18. Now if we compare this, 13 is much lesser than 18. Now if 13 is less than 18, there is no point of checking these elements. So we don't need to go through these elements because 13 is already less than 18, which means we don't even need to check 13, 10, 1, 3. So now we'll update our array and now we only need to search in this region. So now let us go to step 2. So if we need to search through this region, then we might as well update our low. So we can update our low as we can increment it 1 from mid. So we can do 3 plus 1, and which would give me 4. So now from 4th element, I need to go right up to the 7th element, so 7th index. So now let us go to step 2. By the way, in the first step, we have already halved this array. We have already halved the size of the array, and now we are only searching in this region. So we don't need to search in every index again and again. So we have this index to work upon. Now we are currently on step 2. Now again, we do the same process. We find the mid. So mid would be low plus high minus low divided by 2, which is in our case now updated low is 4 and high is 7. We have not changed the high yet. High minus and low would be 4 and divided by 2. Now this would give me 7 minus 4 would be 3 and divide 3 by 2, which would give me 1.5. So the base would be 1 and 1 plus 4 would be 5. So now in our array, the 5th index, the element in the 5th index is 18. Now compare this with our target. So 18 and the target, and looks like we have already matched our target. So 18 is equals to 18. So what this will do is this will return the index 5. So this will return the index 5, and in the index 5 our target is present. So this is how the first iterative binary search algorithm works. So what we're doing is in each step we're exactly halving the size of the array. So we don't have to go through each element again and again. So what would happen if we don't get the target? So if we have kept on halving every time, and if we don't get the element, then we only do this. So we only do the steps until our left is less or equals to right. So if at some point our low becomes, let's say, 2 and our high becomes, let's say, 2, then what would happen is that there would only be one element left in this array. And if one element is left in the array, we cannot further split this array. So this would mean that there was no target in the element in this array basically. So I hope you understood this. Now let me give you a different point of view. Let me explain you this in another way. So let me go down, and so okay, I am going to make a table here. So let us see in how many let me make a table, then you will understand. So I will make a table here. So in here I would do iterations. So iterations. So here would be iterations, and here I would represent the size. So now in first iteration, the size of the array would be n, and in the first iteration you would halve the size of the array, so it would be n divided by 2. In the second iteration, this would be further split, so it would be n divided by 4. In the third iteration, it would be n divided by 8. And similarly, when you go from third iteration up to the kth iteration, this would be n divided by 2 power k. So 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, and similarly 2 power k is 2 to the power k. So in kth iteration, the size of your array would be n by 2 power k, and we would continue iterating until there is one element left in the array. So the condition to stop iterating would be when n by 2 power k would be less or equals to 1. Now if you solve this, and we can now multiply 2 power k on both sides, so this would be n less than equals to 2 power k. And if we further take log base 2, then it would be log base 2 of n, and here it would be k less or equals to k. and this would approximately be, k would approximately be equals to log 2 of n, and this means big O of log n. So this is the complexity. So now next time, if you know the size of the array, then you can initiate, you can at the beginning you can guess the how many iteration it would take to get to get certain element from that array. So before, in this case, the size of our array was 8. So if the size of array is 8, then if we put this if we put the value in this formula, then the iterations would be log base 2 size 8. So this would be how much to the power of 2 would be 8 is 3. So it would take 3 iterations to get an element from an array whose size is 8. And in here we did the same. So it took 3 steps. So now I hope you understood about the first binary search algorithm, which was iterative binary search algorithm. Now let us understand lower bound iterative algorithm. But I think the better approach would be, we have already understood theory about iterative binary search algorithm. Let us first code this algorithm, and then we'll understand theory for this algorithm, and we'll continue. So let us open Visual Studio Code. Here I have my Visual Studio Code open. I have created a file called main.py, and here we will implement iterative binary search. So now I will make a function. So the name of the function will be binary search, and in this function I'll take two things. Which one? First will be the array, and another thing will be the target. Now let us initialize low and high. So now I will represent low as left and high as right. So at the beginning, my left would be 0 and my right would be would be 1 less than the length of the array. So length of array minus 1. So I have initialized my left and right. Now I will create a while loop. So I have to continue iterating on this array until my left is less or equals to right, because when my less is less or equals to right, I have only one element left and I cannot further split the array. So I want to continue iterating until this case, and for mistake I have clicked Ctrl and Enter at once. So okay, now first step, I want to find the mid. So to find the mid, I have left plus right minus left, and we divide by 2. So we found the mid, and now we have to check a condition. Now if in the array the mid index would be is less than the target, which means that the target is in the right side. First of all, we can do one thing. If we can check that if the index in the middle, the mid, if this is equals to the target, then we have found the target. We can immediately return the mid. We can immediately return that index. And if this is not equals to target, then if array mid index is less than target, then this means that, okay, again, now this condition, if array mid is less than target, then this means that the target is in the right. And if target is in the right side, then we want to update our left by adding 1 to the mid. So basically this is this case. So we are adding 1 to the left, because there is no point of searching to the left, because because in this region our target will not be present. We are sure of that. Now another condition would be that now there would only be one condition left, which is the target is less than the array of mid, and if that is the case, then we want to subtract 1 from the mid, and we'll keep on doing this. We'll keep on halving the size of the array, and if we don't find we don't find the element until this case, then this means that the element is not present in the array. Then we can basically return -1. So when we are iterating through this algorithm, at one point this should match and this should return me the index of the array. So let us use this. Let us see if this works or not. So I'm going to define my array. So my array is going to be 2, 4, 6, 8, 10, 12 and 14. And by the way, your array should always be sorted, because if it's not sorted, then we cannot apply this. Because if it's not sorted, we cannot be sure that the element in this would not be the target, right? So I have created my array, and let's say my target here is to find from this array the element 10. Now I print and I will pass the array, and then I'll pass the target to this function. Now let us open our terminal. Now let us run this main.py. So Python 3 main.py, and we can see that it returned me index 4. So let us check this. So 0, 1, 2, 3, 4. Okay, this is our target. So this is working fine. I hope you understood about iterative binary search. Now let us move to the next binary search algorithm, which is lower bound iterative search. So let us continue on that. So lower bound binary search. Now lower bound binary search is similar to this one, but in this case there is one change, and that will make it look very different, and that will make it very confusing. So listen carefully about this. In lower bound, okay, so let us understand with example. So let me take an let me take an array. So I can basically take the same array as above. So I can copy this and paste it right here. Okay, so we're taking the same array. So okay, now our array is the same, and the target is to find the element 18. Now here, first of all, our left, let us say our low will be 0, which is the same as the previous one, but this time our right would be the length of A. Remember, previously we had our right the index 7, which was length of A minus 1, but in this case we have right as length of A, and the length is 0, 1, 2, 3, 4, 5, 6, 7. 3, 6, 7, 8. So length is A. So our right this time is 8. So if we have our right as 8 and our low as 0, and in lower bound binary search algorithm, what happens is that the low will be inclusive, and our right, or we can name this as high, our high which is 8 would be exclusive. So we would only go from 0 to 7. We would not go right up to the 8. So now let us perform each steps and let us understand how lower bound binary search works. So let us go to first step. So step 1. In the first step, we again find the mid. So mid would be low plus high minus low, and you divide it by 2. This is basically the same, because if you look at this, our low is the same as the previous one. So updating the left would be the same. Only thing would be only the difference would be updating the high part. So let us understand that properly. So here in the first step we have found out mid. So our mid would be 8 divided by 2, which would be 4, and 4 plus 0 would be 4. So if we check the fourth index in our array, then it would be 0, 1, 2, 3, 4. That is 17. Now we need to check the condition. Is 17 less than the target 18? Yes, it is. So this condition is true, And if this is true, then we will update our low with mid plus 1. So our low would be 4 plus 1, which would be 5. So now we would not so now we would not 0 1 2 3 4. So now we would only check in this region. There is no point of checking in this region because we are sure that in this region our target is not present, and we can also see that 18 is not present in this region. Now let us go to step 2. In step 2, now remember, until this point our low is 5 and our high is 8, and we would continue this iterative process until our low is less than right. So until our low is less than right, we'll continue this process. 5 is less than 8, so we have to continue step 2. So again, let us find the mid. So mid would be low plus high is 8 minus low divided by 2. So 8 minus 5 would be 3. 3 divided by 2 would be 1.5. So it would be 1, and 1 plus 5 would be 6. Now in our array, if you look at the sixth index, then the sixth index is 0, 1, 2, 3, 4, 5, 6. It's 19. And now we have to check, is 19 less than our target, which is 18? And this is false. 19 is not less than 18. And if this condition is false, then what we do is we have to update high. And this time our high would be the mid, which is 6. So we have to update our high as 6. Now up to step 2, we have our low as 5 and we have our high as 6. Now low is 5 and high is 6, which means the condition still is true. So low is less than high. So we have to continue to step 3. So now let us go to step 3. Again, we have to, okay, so let us see in what region we are searching now. So we have our high as 6. So 0, 1, 2, 3, 4, 5, 6. So now we are only searching in this 2 element. So in this 2 element our target exists. So now let us find mid. So mid would be low plus high minus 5. So low is 5, low plus high is 6 minus 5 divided by 2. And this is 6 minus 5 would be 1. 1 divided by 2 would be 0.5. And if we get the best, that would be 0. 5 plus 0 would be 5. And in our array, the fifth element is, so 0, 1, 2, 3, 4, 5 is 18. Technically we have found the target, but in this case we only care about, is this 18 smaller than our target? Is 18 less than target? Which is false. 18 is equals to 18, not less than 18. So we have to update our high. So our high would be 5. So now up to this point, we have our low as 5 and we have our high as 5. And the now condition for stopping this iterative process is that until our low is less than high, we have to continue this iterative process, but this time it's equal. So we have to stop this iterative process. So this stops, and now we take the latest low. So our low is 5. So we return this low. So when we return this low, we return the fifth index, and in our fifth index, if we check it, 0, 1, 2, 3, 4, 5, this is the target. This is the index where our target is present. I hope you understood about lower bound binary search. Basically, the twist in this from the previous one is that we take length of the array itself rather than length minus 1. So the the right side is not exclusive. So we exclude this. So we only go up to one less than this one. So, and basically the left side is the same. So updating the left side is same to the previous, but updating the right is a little different. So again, if you've understood the theory, so let us go to the practical part. So opening my Visual Studio Code, let me remove my previous code. So now, like we've learned in theory, let us implement exactly like we've learned in theory. So let us create a function. So I've named the function as lower bound. And here again, we will accept array and we'll accept the target. So in this case, the left would be 0, but right would be the length of the array. So right would be the length of array. And now the condition is that until left is less than right, we have to continue. So this, so the condition is this: until this is true, we have to continue the iterative process. So first of all, the same as the previous one, find the mid. So mid would be left plus right minus left divided by 2. And now we have to check if the value in the mid index, which is ARR mid, if this is less than our target or not. And if this is less than our target, so I forget to write a if statement. So if the value is less than our target, then we have to update the low, which is the left this time. So left would be mid plus 1. And if this is not the case, else, then we have to update the right side. So we have to update the right and we have to set as mid. And we have to continue this again and again. And after one point, when left, this condition will be false, which means that when left would be equals to right, we would return the left, and that would be the index where target is present. So let us use this. So let us make an array. So 2, 4, 4, 6, 8, 10. And I would choose the target as 5. So I want 5. So here, let us use that function. So lower bound, pass the array and pass our target. So save this, come to our terminal, clear, and let us run main.py, and it returns index 2. So if we check 0, 1, 2, and this is the index where our target is present. So I hope you understood about two types of binary search algorithms: iterative binary search algorithm and lower bound iterative algorithm. And I hope you understood about this part, where how many iterations it would take to find an element in certain size array.